Hey 8th graders, how are you guys doing today? I hope that you got out to enjoy the beautiful day yesterday. Kind of nice starting our day with some sunshine. And so what we are going to do today is work on solving these systems of equations, but we're going to start by solving them with graphing today. So last time we were just kind of checking to see if certain ordered pairs made solutions, but now we're going to solve and find the solution by graphing. So the first thing is that sometimes you can solve these systems mentally, and we did those with some word problems on Monday. But for example, this first one, it says, I'm thinking of two numbers, their sum is 5 and their difference is 1. Well, what two numbers could add up to 5, but when you subtract them, you would get 1? Well, I think of 3 and 2. If you add them, you get 5, and if you subtract them, you get 1. So your ordered pair, 3 would be the x, and 2 would be the y. But if you go to the next one, it says, I'm thinking of two numbers. One of the numbers is 2 less than 2/3 of the number, and the other, and also 5 more than 3 times the other number. What are they? So this is the two equations, which you guys might have a hard time coming up with anyways. But then the harder fact is, like, how do you even think about what numbers would make both of those true? So rather than just kind of spend the brain power doing that, we are going to solve these systems by graphing. And you guys know how to graph these lines from chapter 5. They are in slope-intercept form. So we can go to our graph. You can start at -2. Remember the y-intercept. Your slope is 2/3. So I'm going to go up to 1, 2 over 3. 1, 2, 3. Up to 1, 2 over 3. You could also reverse this. Go down 2 and the other direction 3. And I'm just going to use a pad of paper here to make my straight line. Okay, so now I'm just going to grab a different color and do my other equation. I start at +5. 1, 2, 3, 4, 5. And my slope is a 3 over 1. Now, can I move up 3? No, but I can go down, and I can go down 3, left 3. 1, 2, 3, 1, 2, 3, 1. 1, 2, 3, 1. And you guys can see, I kept going with my dots there, where these lines are going to cross. Okay, so the solution is the point where they cross. So it's 1, 2, 3, and down 4. So -3, -4 is the location that they meet. That is the only point that is going to make your system true, because it's the only location that your lines will cross. Okay, to check your answer, you can put this in. -4 goes in for your y, -3 goes in for your x. This gives you -4 equals 2/3 times 3 is a -2. -2 minus 2 is -4. So does -4 equal -4? Yes. Your other one, put your -4 in, put your -3 in. -4 equals 3 times -3 is -9 plus 5. So -4 equals -4. It's true. So when they both come out true, it means that you did it correctly. So the solution to a system of equations is where their graphs intersect. Because that ordered pair satisfies both equations. Okay, it makes both true. So with this, there are 3 things that can happen when we graph these lines. And maybe if you guys just take a second and peek at these equations, you can kind of predict what's going to happen. Okay, so the first situation, remember, if they're both in slope-intercept form, we're going to be doing a lot of graphing in slope-intercept form. You put a 1 in front of there. So you start at -3. 1, 2, 3. Your slope is -1 over 1. So down 1, right 1, down 1, right 1, up 1, like this. Okay, and then my other one, you kind of might want to visualize this flipped around 1/2 x plus 3, so you can see the equation there. So I'm going to start at +3, 1, 2, 3, and it is up 1 over 2, up 1 over 2. So I could reverse it, go down 1 over 2, down 1 over 2. And you guys can see where they are going to cross. So the solution is 1, 2, 3, 4, -4, +1. Okay, so we go on to the next situation. This one, remember, if there's nothing there, there's a 0. So this one starts at 0, 0. Then I'm going to go down 2 over 1, down 2 over 1. It is important to graph these pretty carefully so you get those points. And then my other one is going to start at +5. 1, 2, 3, 4, 5. 1, down 2 over 1, down 2 over 1, down 2 over 1. And what do you guys notice about these two lines? What do you notice? They're parallel. Are they ever going to cross? No. So if they never cross, are you ever going to find this point? No. So what happens is this is a no solution. Okay. Then the next one, we'll graph the first line. Starts at +1. The slope is -2/3. So down 2, right 3. 1, 2, 3. Down 2, right 3. Graph this line. And I'll just do up 2. Okay, and then again, sometimes you have to manipulate the equation or just flip things around. So if you look here, I'm going to move this -2/3 x plus 1. Well, what do you notice before we even graph? They're the same equation. So what do you think happens if they are the same exact line? What are the solutions to the system? Everything. Every ordered pair that makes one true will make the other true. So this one is infinitely many solutions. And you guys have seen that before when we're solving equations, just not with a system yet. So these are the 3 different situations that you guys are going to arrive at. So what I am going to do, so this video does not take you forever, I am going to do the first 2 here, and then I'm going to let you guys finish them, and I'll post a picture of this so you guys can check your work. Okay, so the first one here, I start at -3, 1, 2, 3, and my slope is +1/4, so up 1 to the right 4. And then I can do reverse, down 1, 1, 2, 3, 4, and I can go the opposite. And then I can do the same thing. start at positive 2. And then my slope, remember there's nothing there, there's a 1. So down 1, over 1, down 1, over 1. Sometimes it's easy just to use your slope to find that point of intersection. So where do they meet? 1, 2, 3, 4. So positive 4, down 2. So positive 4, negative 2. Okay, so let's do another one. So I'm going to start at positive 3. My slope is 3. Remember, if it's a whole number, just put it over 1. So up 3, 1, 2, 3, over 1. Down 3, 1, 2, 3, over 1. And then I can draw my line. And then my next one, I'm going to do negative 2 is where I start. My slope is up 1 over 2, up 1, right 2, up 1, right 2. And I can do the reverse, and that kind of helps me find exactly where my points cross. So this one is going to be negative 2, and then it was 1, 2, 3 down, negative 3. And to check, you can plug them both into the equation and check. So I did the first 2. You guys finish those up, and then like I said, I'll post a picture. So we're going to move on to the last little part here. It says, for the following systems, let's decide if there will be one solution, no solution, or infinitely many solutions. So I'm going to put some notes here. This right here is if they cross. No solution means they are parallel. And infinitely many solution means that they are the same line. Okay. So what we're going to be looking for is basically their slopes, okay, and their y-intercepts. So if the slopes are the same, but the y-intercepts are different, that tells us that this is going to be 2 parallel lines. Okay, so let's make a note of that. Same slope, different y-intercept equals parallel. And you don't have to do this every time, but this is good for our notes. So this means no solution because they will never cross. Okay, your next one. Right away, they have different slopes because negative and a positive, they're different. So this means that they are going to cross. You're not telling me where, you're just telling me how many solutions they're going to have. The next one, this one's tricky because the equations are not in the right form. So let's take this equation real quick. And let's switch it around. So y equals 2 minus x. Let's flip-flop this. Y equals negative x plus 2. Okay, negative x. So remember, this is a negative 1x. This is just a 1x. Different slopes means that there's going to be one solution. They are going to cross somewhere. Okay, up at the top. Different slopes. This has a slope of 4. This has a slope of negative 3. That means they're going to cross someplace. So one solution. Next, same slope, same intercept. So if we have the same slope and the same y-intercept, that means they're the same line. So this means infinitely many solutions. Next one, again, these are switched around a little bit. You might want to envision this like this. I'm not moving it to the other side, so as long as I keep they're both positive, as long as I keep that with it, I can move them. This is a slope of 1, this has a slope of 1. What does that mean? That means they're parallel. No solution. Okay, so keep those in mind. Okay, the last little part here is word problems. This is really handy when you are trying to find the solution of certain word problems. So it says sometimes the best way to represent and solve word problems is by graphing a system of equations. Your friend has $200 and saves $20 per week. You only have $60, but you are going to save $40 per week. When will you both have the same amount of money? So you can create a table, or you could write an equation. Either way works. Okay, I know some of you probably want to jump to writing that equation because technically you guys can graph that already. So if I were going to write an equation for your friend, I would say that they're going to save $20 a week and they started at $200. And if I were going to write an equation for you, I would say that you're going to save, $40 a week, and you are only starting with 60. So you could probably go and graph those 2 points. I'm also going to fill out the tables just to show you the differences here. So at 0 weeks, we start off, your friend starts off with $200, and then this is going to go up every time. So $220, $240, $260, $280, $300, $320, $340, $360, $380, and after 10 weeks there'll be $400 in there. Now you started off with $60, but you're going to save $40 every week. So it's going to go up to 100, then 140, then 180, and then 220, and then 260, then 300, 340. Oh, look at there, week 7, 380, 420, and 460. So after 10 weeks, who's got more money? You do. Now we can prove this by graphing as well. Again, you're going to start at 200 for your friend. That's how much they had in the bank. And if you look at what we went up by, they went up by ones, but this went up by 20s. So 20, 40, 60, 80, 100. So pay attention to what they're labeled. So after 1 week, they're at 220, and their graph is going to do this. And you can double check, like 5 was at 300, so I knew I was doing that right. Okay, and then for yourself, you're going to start at 60, so way down here, 20, 40, 60. But you are going up by 40s. So it's 2 points, or 2. And there you go. Oops. Ooh, sorry, that was bad. There we go. Ignore that one. I graph my 2 lines. See guys, I even make mistakes when I record videos at home for you. Shows that I'm human, right? You can just see Libby rolling her eyes. I miss you guys, by the way. Even the smart aleck ones. I hope you're smiling. Okay, so there, this is 6, 7, so you can see here that we met at 7 and 340. Okay, so the solution would be in 7 weeks, you will both have $340. Okay. So, the next one, it says, solve the word problem below by graphing the systems of equation. Jack buys 20,000 worth of stock in the Crummy Company and starts losing 2,000 per week. Sally buys 2,000 of the Incredible Incorporated and starts earning. So these are going opposite directions, and that's okay. So let's do Jack. Let's write an equation. Y equals. Now, he started with $20,000 of stock, but he is losing $2,000 per week. Then Sally, she starts, and she only spends $2,000, so she starts with $2,000, but she increases hers $1,000 per week. Now, I actually wrote these systems I mean, they're kind of in slope-intercept form, but not perfect. You might want to look at them like this. Our slope is negative. I just thought it would help you to see them if I wrote them the other way first. It just fits better with the story problem. This one's going up by 1,000 and we started at 2,000. This is probably better for graphing. So let's go to our graph now. I'm going to start with Jack, and he started at 20,000. So he started up here, but he is going down 2,000 every week. And these, let's count. They look like they go by ones. 1, 2, 3, 4, 5, 1,000. So he's going to, every time he goes over, he's going to go down 2. So his decrease is pretty quick. Then we have Sally, and hers started only at 2,000, but it goes up 1,000 every week. Slow and steady, right? And you guys can see here where they're going to cross. I need a longer line and another piece of note paper. Maybe I should just get a ruler, huh, Ian? I think my kids stole my ruler. I'm gonna blame them anyway. So where do they meet? They meet right here. So how many weeks? 6 weeks. And it'll be 5,000, 6, 7, 8,000. And that is how you solve systems of equations by graphing. So, good luck, you guys. Make sure you message me any questions.